Hello students, now we will discuss heat and thermodynamics. Heat and thermodynamics. Next topic is latent heat. During change of state from solid to liquid or liquid to gas, the temperature of the substance does not change upon heating. Therefore, the amount of heat supplied during change of state of the substance is called latent heat. It is of two types. Number one, latent heat of melting. The amount of heat required to melt the unit mass of substance at its melting point is called latent heat of melting. It is denoted by capital L melting. Therefore, the amount of heat required to melt mass m of the substance at its melting point is given by Q is equal to m into capital L melting. Let it be equation number 1. Number 2, latent heat of evaporation or boiling. The amount of heat required to evaporate the unit mass of liquid substance at its boiling point is called latent heat of evaporation. It is denoted by capital L boiling. Therefore, the amount of heat required to boil mass m of the liquid at its boiling point is given by capital Q is equal to m into L boiling. Let it be equation number 2. So these are the two latent heats. Latent heat of melting and latent heat of evaporation or boiling. Now evaporation, the spontaneous process of changing liquid into vapor below its boiling point is called evaporation. So this is a container and it contains water. Consider a molecule of the water well within the liquid and surrounding it a sphere of influence, mean the molecule within this sphere attract these molecules. As in all the direction the force exerted on this molecule is same, so net force on this molecule is 0. See in the diagram, it is attracted from all the direction by same force, so net force is 0. So according to Newton's first law, it is moving freely. But if molecule is close to the surface, see in the diagram, the sphere of influence, some part is outside the liquid and there is no liquid molecule or water molecule. The water molecule attracting in downward is more. Therefore, when molecule reaches at this point, a downward force start acting which try to pull it back. If molecule is moving toward the free surface, due to this force, it turn back within the liquid. See in the diagram, this is a molecule and moving in the upward direction, and due to this downward attraction, it turn back within the liquid. But if a molecule has sufficient energy so that it can overcome this backward dragging force, it go to vapor state. See this, the molecule has sufficient energy and go to vapor state after overcoming the backward dragging force. So molecule with large energy can go to the vapor state, and there are more molecules which has much more energy and they can go to vapor state. See in the diagram. Now we see that only those molecule goes into vapor state which has more energy, leaving behind molecules having less energy. Therefore temperature decreases. If temperature decreases mean water become cool. Hence we prove that evaporation causes cooling. That is, evaporation causes cooling. Now factor on which rate of evaporation depends. Number 1, temperature. The rate of evaporation increases with the increase in temperature of the liquid, because if temperature increases, the energy will increase and more molecules gain energy so that they can go to vapor state. So therefore the rate of evaporation increases with the increase in temperature of the liquid. Number 2, free surface area, because during evaporation the liquid changes into vapor from the free surface area of the liquid. Therefore the rate of evaporation increases with the increase in free surface area of the liquid. That's why to dry the clothes we spread them only to increase the free surface area. Third one, humidity. Water evaporates fast in dry air as compared to humid air. In dry air, the number of water vapor in the air is less, so there is a possibility of liquid molecules go to the vapor state. If the air is saturated, the water does not evaporate, means net evaporation is zero. The molecule which go to vapor state, same number of molecules in the vapor state go to liquid, that is called condensation, so that net evaporation is zero. Fourth one, wind speed. If wind blow fast over the free surface area of the liquid, then liquid evaporates fast and vice versa. Now fifth one, nature of the liquid. The rate of evaporation also depends upon the nature of the liquid. Some liquids evaporate fast and are called volatile liquid, and for example ether, petrol, etc. Whereas some liquid does not evaporate even upon heating, hence and are called non-volatile liquid. That is, some liquid does not evaporate even upon heating and are called non-volatile liquid, for example mercury and vegetable oil, etc. So these are the factors on which the rate of evaporation depends. Vapor pressure. The pressure exerted by the vapors over the surface of the liquid is called vapor pressure. Now boiling. Because the rate of evaporation increases with the increase in temperature of the liquid, therefore amount of vapors therefore the amount of vapors over the free surface area of the liquid increases, and hence the vapor pressure over the free surface area of the liquid increases. When the vapor pressure over the free surface area of the liquid becomes equal to the external pressure, then the liquid is said to be start boiling, and the temperature at which the vapor pressure over the free surface area of the liquid becomes equal to the external pressure is called boiling point, or you can say the temperature at which liquid start boiling is called boiling point. The above definition show that the boiling point of the liquid depends upon the external pressure over the free surface area of the liquid. Therefore, the boiling point of water increases with the increase in external pressure over the free surface area of the liquid and vice versa. It is the principle of pressure cooker. As in pressure cooker, we increase the external pressure, due to which the boiling point of the liquid inside the pressure cooker that goes on increasing. So this is the principle of pressure cooker. That is, the boiling point depends upon the external pressure over the free surface area of the water. Now difference between evaporation and boiling. Difference between the evaporation and boiling. In the left side is boiling, in the right side is evaporation. First difference is boiling is a fast process, whereas evaporation is a slow process. Number two, it takes place at the particular temperature. That is, it takes place at a particular temperature called boiling point. And it takes place, mean evaporation takes place at any temperature below the boiling point. Number three, it does not depend upon the free surface area, temperature, humidity, etc. And in evaporation, rate of evaporation depends upon the free surface area, temperature, humidity, etc. It depends upon all the factors. Now fourth one, it takes place throughout. Well within the liquid is changing into vapor state at the boiling temperature. Now in evaporation, it takes place from the free surface area of the liquid. That is, only from the free surface area of the liquid changes into vapor state. So these are the four difference of between boiling and evaporation. So thank you very much.